James Webb will go where no other telescope has gone before.
I think the greatest promise of the James Webb Space Telescope is it will answer questions that none of us have imagined or thought to ask.
What exactly lies at the edge of the observable universe? That question has intrigued humanity for centuries, sparking endless curiosity and speculation among scientists and space enthusiasts. But now the James Webb Space Telescope might be on the brink of answering that very question. With its incredibly powerful lenses reaching deeper into space than ever before, it has recently made a groundbreaking discovery about what's lurking at the very edge of our observable universe. Before diving into that, we need to understand what the observable universe actually is. It includes everything we can currently detect, study, and analyze from Earth, or with the help of our space telescopes and probes. This means every star, every galaxy, every traceable object within reach of our instruments. Those all fall under the umbrella of the observable universe. Now you might be wondering, what's the difference between the observable universe and the universe with a capital U? It's actually pretty simple. The observable universe is just the portion we can study. The entire universe, on the other hand, might be far, far bigger, possibly even infinite, and beyond our capacity to fully comprehend or observe. As it stands, scientists estimate the observable universe to have a diameter of about 93 billion light-years. To put that into perspective, 1 light-year, the distance light travels in a year, is around 5.88 trillion miles, or 9.46 trillion kilometers. Multiply that by 93 billion, and we're looking at a cosmic stretch of roughly 546.84 billion trillion miles, or 878.58 billion trillion kilometers. The sheer scale is so enormous, it's almost impossible to truly grasp. So why is the universe so incomprehensibly vast? The answer lies in how it all began. According to the Big Bang Theory, the universe came into existence about 13.8 billion years ago through an enormous explosion. That initial burst of energy caused the universe to expand rapidly, and it's been expanding ever since. Not only that, but the expansion is accelerating thanks to mysterious forces like dark energy that we still don't fully understand. As the universe grew, matter began to clump together under the force of gravity, gradually forming stars, galaxies, and eventually entire planetary systems, including our own solar system. Over billions of years, these structures became more complex and diverse, giving rise to the mind-blowing variety of cosmic phenomena we see today. And yet, for all its grandeur, the universe is mostly empty. To help visualize just how empty, imagine shrinking our entire solar system down to the size of a quarter. On that scale, the closest star would still be about 2 soccer fields away, and that's just within the Milky Way, one galaxy among billions in the observable universe. So why can't we see the whole universe? There are 2 main reasons. First, light doesn't travel instantly. It takes time to move through space. When we observe distant objects, we're actually seeing them as they were in the past. The farther away something is, the further back in time we're looking. So, when we stare at distant galaxies, we're not just seeing far, we're looking billions of years into the past, uncovering the universe's own history. The second reason is the ongoing expansion of space. Think of dots on a balloon being inflated. As the balloon grows, the dots move further apart. The same thing is happening to galaxies in the universe. They're drifting away as space itself stretches. This stretching also affects light, causing it to shift toward longer wavelengths. That shift, known as redshift, means some objects are moving away so fast that eventually their light will never reach us again. Given all that, it makes sense that we haven't seen the entire universe yet, and maybe never will. The concept of the universe's edge is something that has fascinated thinkers for ages. What's out there? What lies beyond the observable? While we don't have all the answers, 3 fascinating theories offer some compelling possibilities. The first theory is that the universe goes on forever, without any end. It's built on the cosmological principle, which suggests that the universe is isotropic, meaning it looks pretty much the same in every direction. If that's true, then the universe could extend endlessly with no boundaries or edges, just infinite space continuing forever. The second theory takes a different approach. It proposes that the universe is finite but still doesn't have a clear edge. Think of it like a giant sphere. If you kept traveling in one direction, eventually you'd loop right back to where you started, much like walking in a circle on the surface of the Earth. So even though it's finite, you'd never reach a wall or a stopping point. The third theory is perhaps the most mind-bending of them all, the multiverse theory. This idea suggests that our universe is just one of countless others. Imagine a vast collection of parallel universes, each with its own unique set of physical laws and characteristics. Some could be completely separate, never interacting with ours. Others might be somehow connected in mysterious ways. So far, we've explored the different theories about what could lie at the edge of the universe. But to truly understand these mysteries, we need powerful tools. And that brings us to one of the most groundbreaking instruments ever built, the James Webb Space Telescope. This incredible telescope has given scientists the ability to look far back in time and discover things we never even imagined. With its cutting-edge technology, it allows astronomers to peer into the earliest moments of the universe. And recently, it made a jaw-dropping discovery. According to a study published in the journal Nature, the James Webb Space Telescope found 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Now, that might not sound unusual at first, but here's the catch. Scientists were only expecting to find small, newly formed galaxies from that era. Instead, they stumbled upon these enormous, mature galaxies that defied all expectations. Some of them are as developed as our own Milky Way, which is over 13 billion years old. The amount of mass in stars within each of these galaxies is astonishing, several billion times greater than the mass of our Sun. One of them might even weigh as much as 100 billion suns. For comparison, the Milky Way has a stellar mass of about 60 billion suns. That's how colossal these early galaxies really are. How does the James Webb Space Telescope manage to find such things? It sees in infrared light, picking up the faint glow of ancient stars and galaxies that have been around for billions of years. That means it can literally look back in time, giving us a snapshot of what the universe looked like roughly 13.5 billion years ago. And here's where it gets even more fascinating. The universe itself is believed to be around 13.7 billion years old. So when scientists found these gigantic galaxies from just a few 100 million years after the Big Bang, it threw everything into question. It's like rewriting everything we thought we knew about cosmic history. They've even given these galaxies a nickname, universe breakers, because they've shattered nearly every model of early galaxy formation. Up until now, scientists believed galaxies began as small clouds of stars and dust, slowly growing over time. But these universe breakers, they showed up big and bold right at the start. When the first data and high-res images from Webb were released in July 2022, researchers were stunned. They couldn't believe what they were seeing. These galaxies appeared as bright, distinct points of light, and for a moment some even questioned if the data was being misread. But no, it was real. Using spectroscopic techniques to study light at different wavelengths, astronomers were able to gather detailed information about these galaxies, including their size, composition, and distance from Earth. And here's the kicker. This discovery wasn't even on the initial list of things scientists hoped to uncover with the telescope. It completely surpassed expectations and came much sooner than anyone predicted. What's more, there's still some mystery around what exactly was discovered. While it's likely that most of these are galaxies, there's a possibility that some could be something else entirely, like hidden supermassive black holes. And if that's the case, then the implications are even more staggering. Here's another game-changing realization. Scientists now believe the known mass of stars in the universe might be up to 100 times more than we previously thought. And that's even if we consider just half of the galaxies found in this sample. At the same time, thanks to the incredible reach of the James Webb Space Telescope, an international team of astronomers made another astonishing discovery. They've confirmed the existence of the oldest and farthest galaxies ever observed. These galaxies take us all the way back to a time when the universe was still in its infancy, less than 400 million years after the Big Bang. The light from these ancient galaxies has traveled for more than 13.4 billion years to reach us, and the James Webb Space Telescope was able to detect it. Much like the early work done by the Hubble Space Telescope, the first images captured by Webb showed countless potential galaxies scattered across the sky. But this time, thanks to detailed spectroscopic observations, astronomers confirmed the existence of 4 of these distant objects. That confirmation allowed scientists to analyze their physical properties and precisely measure how far away they are. To determine the distance to a galaxy, astronomers rely on a concept known as redshift. So, what exactly is redshift? As the universe expands, the light from distant galaxies stretches out, moving toward longer, redder wavelengths. This is due to a phenomenon called the Doppler effect. Think of it like the change in pitch of a passing siren. The same principle applies, but instead of sound, it's light. Although redshift estimates can be made using filtered photos, the most accurate way is through spectroscopy. By breaking the galaxy's light into its individual wavelengths, scientists can get precise measurements of how far away these objects are. In this new discovery, astronomers focused on 4 galaxies with redshifts greater than 10. That means they are incredibly far away. 2 of these galaxies had been seen before by the Hubble Space Telescope, with redshifts confirmed at 10.38 and 11.58. But the James Webb Space Telescope went even further. It found 2 additional galaxies with even higher redshifts, 12.63 and a record-breaking 13.20. That last number corresponds to a time period roughly 13.5 billion years ago. We're talking about peering into the deepest past of the cosmos, uncovering history written in light. All of this was made possible through a groundbreaking initiative known as the James Webb Space Telescope Advanced Deep Extragalactic Survey, or JADES for short. This ambitious program was given over a month of dedicated telescope time to delve deeper into the early universe than ever before. The seeds of the project were planted in 2015, when a team of researchers proposed it. Today, it's an international collaboration of more than 80 scientists from 10 different countries, all united in one mission to unlock the secrets of our cosmic beginnings. The JADES team began by using the near-infrared camera, or NIRCam, to observe a small patch of sky, including a legendary region known as the Hubble Ultra Deep Field. For more than 20 years, astronomers have studied this tiny region using the world's most powerful telescopes. Now, by observing it across 9 different infrared wavelength bands, the James Webb Space Telescope managed to identify nearly 100,000 distant galaxies, each one billions of light-years away. Next, the scientists turned to another powerful instrument aboard the telescope, the Near-Infrared Spectrograph, or NIRSPEC. Over a 3-day period, they collected light from 250 faint galaxies. This allowed them to analyze the composition of gas and stars inside those galaxies and obtain highly accurate redshift values. With this kind of data, astronomers could determine just how bright these galaxies actually are, estimate how many stars they contain, and gain deep insights into how galaxies have evolved over time. Studying galaxies is surprisingly similar to understanding people. The earliest stars in a galaxy have a lasting influence on its future development, just like how our childhood experiences shape the course of our lives. Right now, we're living through an extraordinary era in astronomy. The James Webb Space Telescope is helping us answer countless questions about how galaxies come to be, grow, and change across billions of years. This deep space observatory is truly transforming what we know about the cosmos. From galaxies and planets to stars and mysterious phenomena, the telescope is uncovering breathtaking discoveries one after another. Since its launch in December 2021, Webb has been on a mission that could last for up to 2 decades, and it's only just getting started. Compared to the Hubble Space Telescope, Webb is in a league of its own. Its capabilities have raised the bar for what we can expect from space exploration. Ever since the telescope's flawless deployment, the scientific world and the general public has been buzzing with excitement. People everywhere are diving into the raw data, editing and enhancing images, and marveling at what they see. When those first photographs arrived in July, they completely changed our view of the universe. Webb showed us cosmic details we've never seen before. It's like opening a new window to the universe and realizing there's so much more to discover. With its cutting-edge infrared technology, the James Webb Space Telescope has opened up a new era of cosmic discovery. Within mere days of becoming operational in June 2022, it revealed thousands of previously unknown galaxies, more ancient and distant than any detected before. But the telescope's true power goes beyond imaging galaxies. It allows scientists to collect and analyze an abundance of light from objects like exoplanets and young stars. This light holds vital clues about their chemical makeup, structure, and even potential to host life. By peering deep into space and catching the faintest glimmers of light from the universe's earliest days, the telescope has already unveiled some astonishing findings. One standout discovery is what might be the oldest black hole ever observed, a supermassive one, no less. This behemoth, weighing in at about 9 million times the mass of our Sun, was found nestled at the center of a galaxy that took shape just 570 million years after the Big Bang. This observation sheds light on a time known as the Cosmic Dawn, a mysterious era during which many black holes emerged and rapidly grew. The formation and behavior of these powerful objects continued to baffle astronomers. Some of them emit incredible bursts of light as material spirals into their gravitational pull, creating what we call active galactic nuclei, or AGN. Among these, quasars are the most extreme. These luminous engines are powered by black holes billions of times more massive than the Sun, producing light output that can outshine entire galaxies. As scientists reach deeper into space, they're able to detect more of these ancient and energetic phenomena. Using its mid-infrared and near-infrared capabilities, the James Webb Telescope can scan the skies for black holes using built-in spectrographs to dissect the incoming light. This reveals hidden frequencies and helps identify what kinds of materials are present, even from galaxies billions of light-years away. In one breakthrough, astronomers noticed something unexpected: a faint heated signature around a distant black hole, a subtle radiation pattern that was carefully preserved in the incoming light. This signature hinted at intense activity occurring very early in the universe's history, possibly revealing a key stage in black hole development. But despite all this progress, there are still plenty of mysteries. One of the biggest questions is how black holes formed so quickly after the Big Bang. Were they the result of rapidly collapsing gas clouds? Or did they emerge from the explosive deaths of the first massive stars? One possible clue lies in what's known as population 3 stars. These hypothetical stars are thought to have existed just 200 million years after the Big Bang, made almost entirely of hydrogen and helium. They would have been massive and unstable, exploding in brilliant supernovae that left behind black holes. If such black holes formed early enough, they could have grown very large by rapidly swallowing surrounding matter, especially in the dense environments of the young universe. The search for answers continues, with scientists working closely with the team behind Webb's MIRI to decode the signals coming from these ancient black holes. This effort may also shed light on another remarkable discovery, a protocluster of 7 interacting galaxies. Initially detected by the Hubble Space Telescope, this grouping is the most distant known galaxy cluster. Simulations suggest it will eventually evolve into one of the oldest and most massive clusters ever observed, containing a total mass about 100 times greater than that of the Milky Way. While Hubble identified the galaxies, it couldn't confirm their exact distances due to limitations in sensitivity. Imagine looking down from a mountaintop and seeing several cities in a line. You can tell they're in the same general direction, but not how far apart they are. That's where the James Webb Space Telescope changed everything. Its instruments provided the precision needed to confirm that these galaxies are not only aligned visually, but also physically close in space, forming a true cluster. These kinds of discoveries are incredibly rare and difficult to come by, but they're essential for understanding how the universe grew and evolved. And while it's unlikely that Webb will stumble upon another protocluster exactly like this one, the upcoming Nancy Grace Roman Space Telescope will take the search even further. Scheduled to launch in early 2027, it will offer a view of the sky that's more than 100 times wider than Webb's, vastly improving our chances of spotting more early galaxy clusters. With every new image, Webb brings us closer to answering age-old questions about our place in the cosmos. Its ability to capture the faintest, most ancient light is turning speculation into science, helping us piece together the universe's vast and complex story. And perhaps the most thrilling part, we're only just beginning to uncover what's out there. Back to the discoveries made by the James Webb Space Telescope, it's fascinating to reflect on how far exoplanet research has come. Back in the 1990s, the idea of planets orbiting other stars was just beginning to gain serious traction thanks to advances in detection techniques. Today, we've cataloged over 3,000 confirmed extrasolar planets, though only a handful have been directly photographed. This is because most exoplanets are incredibly far away, and their light is overwhelmed by the brightness of their host stars. Astronomers typically detect them when the planet crosses in front of its star, a method known as the transit technique, which causes a subtle dip in brightness. But the game changed when the James Webb Space Telescope entered the scene. With its advanced instruments, including coronagraphs that block out the overwhelming starlight, Webb enables scientists to directly observe some exoplanets. One remarkable case is SHIP 65426b, first spotted in 2017 using the SPHERE instrument. But it wasn't until September 2022 that it was directly imaged by the James Webb Telescope. What makes HIP 65426b truly special isn't just the fact that it's a massive gas giant, about 12 times the size of Jupiter. It's also how distant it is from its star. It orbits at a distance roughly 100 times greater than Earth's distance from the Sun. That's more than double the distance between Pluto and the Sun, giving astronomers a clear view unobstructed by the glare of the host star. James Webb's contributions go beyond exoplanets. Take the Phantom Galaxy, also known as Messier 74. When viewed with Webb's infrared instruments, it becomes a vivid spiral of star-forming regions, far more detailed than what Hubble captured in visible light. Hubble's view highlighted cooler stars and glowing gas in electric blue, while Webb's sensors picked up the heat signatures of newborn stars nestled within the galaxy's arms. Scientists then combined both sets of images into a composite that reveals an incredibly rich and layered picture of this galaxy. This dual-view approach not only paints a more comprehensive cosmic landscape, but also helps astronomers determine the mass and age of star clusters more precisely. The James Webb Space Telescope has also proven vital in studying the dusty and mysterious regions of space. Its sensitivity to infrared light allows it to detect the faintest signals from dust particles scattered across interstellar space. This capability has provided insights into how stars form and how dust behaves in the vacuum of the cosmos. A perfect example is Webb's capture of WR-140, a massive Wolf-Rayet star in its final life stages. What stunned scientists wasn't just the image of the star itself, but the series of concentric rings radiating outward in a peculiar, almost geometric pattern. Initially, it might seem like a glitch in the imaging process, but these rings are real. They result from intense stellar winds and dust interactions between WR-140 and its smaller companion star, shaping the surrounding matter into rippling, layered structures. In the constellation, Virgo lies one of the most extensively studied exoplanets, WASP-39b. Situated about 700 light-years from Earth, it's a scorching gas giant about the size of Saturn. What's particularly interesting is how close it orbits its star, about 8 times closer than Mercury is to our Sun. Thanks to Webb, astronomers have been able to examine this planet's atmosphere in unprecedented detail. By analyzing how starlight filters through the atmosphere during a transit, they've uncovered signs of complex molecules, including carbon dioxide and water vapor, essential clues in the ongoing search for potentially habitable worlds. These discoveries reinforce the idea that Webb is doing exactly what it was built to do, pushing the limits of our understanding and reaching deeper into the universe than ever before. From peering into the hearts of galaxies to identifying black holes, studying stellar nurseries, and analyzing the atmospheres of distant worlds, the telescope is exceeding expectations. It's ushering in a new era of astronomy where previously unimaginable observations are now becoming routine. And this is only the beginning. With many more years of operation ahead, the James Webb Space Telescope is poised to continue delivering groundbreaking science that will reshape our understanding of the cosmos for generations to come.